Hello everyone, welcome to our channel. Today, we're exploring an important topic from your Class 9 Science syllabus, work and energy. We'll break down these fundamental concepts and see how they impact our daily lives. Let's get started. First up, let's talk about work. In scientific terms, work is done when a force causes an object to move. For work to be done, two things must happen. A force must be applied, and the object must move in the direction of the force. The formula for work is, where theta is the angle between the force and the direction of motion. If the force is applied in the direction of motion, E theta is 0 degrees and ACOS 0 is 1. For instance, if you push a box with a force of 10 newtons over a distance of 5 meters, and the force is applied in the direction of motion, the work done is, where the unit of work is the joule, J. Now let's dive into energy. Energy is the capacity to do work. It comes in various forms such as kinetic energy, potential energy, and mechanical energy. Kinetic energy is the energy of an object in motion. The formula for kinetic energy is where m is the mass of the object and v is its velocity. For example, if a car of mass 1,000 kilograms is traveling at 20 meters per second, its kinetic energy is. Potential energy, on the other hand, is the stored energy due to an object's position or state. The formula for gravitational potential energy is potential energy, PE, equals mgh, where m is the mass, g is the acceleration due to gravity, and h is the height. For example, if a 5-kilogram book is placed 2 meters high on a shelf, the potential energy is PE equals 5 kilograms times 9.8 meters per second squared times 2 meters, which equals 98 joules. Transition to conservation of energy. A key concept in physics is the conservation of energy. This principle states that energy cannot be created or destroyed, only converted from one form to another. In a closed system, the total energy remains constant. For instance, in a pendulum, the energy constantly shifts between kinetic and potential forms. At the highest points, potential energy is maximum and kinetic energy is minimum. At the lowest point, kinetic energy is maximum and potential energy is minimum. Transition to power. Next, let's discuss power. Power is the rate at which work is done or energy is transferred. The formula for power is power equals work divided by time. For example, if a motor does 5,000 joules of work in 10 seconds, the power output is power equals 5,000 joules divided by 10 seconds, which equals 500 watts, where the unit of power is the watt. Transition to work-energy theorem. Finally, let's explore the work-energy theorem. This theorem states that the work done on an object is equal to the change in its kinetic energy. Mathematically, work equals delta KE. For example, if a car's speed increases, the work done by the engine is converted into kinetic energy. Conversely, if the car slows down, the kinetic energy decreases and the work is done by friction. Closing remarks. So, to recap, we've covered work, energy, power, and the work-energy theorem. These concepts are fundamental in understanding how forces affect motion and energy. If you found this video helpful, please like, subscribe, and hit the bell icon for more science content. Thanks for watching and see you next time.